picking up right where we left off. Sorry about that. Number 2. So we talked about domain, and domain is as far left as the graph goes. So if you focus right on the left side of this graph, it's hard to do with my elbow hitting the microphone all the time, but right there. You'll notice that the furthest left this goes in relation to our x-axis, which remember all the domain cares about is x-axis, does not care about the y-axis, doesn't care that this point is at 12. It doesn't matter. It's focused on just the x-axis. It starts around negative 2.5, negative 2.5, right? Now, the furthest right that our graph goes would be all the way here. Now, again, I do not care that this is down here at negative 10. That doesn't matter to me. What I'm focused on is how far right it has gone. So the wall that it hits here on the right, you can see, is about x equals 3, right? Remember, you're only focused on how far left and right the graph is in relation to its x-axis. So negative 2.5 is the lowest version to the left, and 3 is the highest version to the right. Now, both of these points are closed circles, so they both equal, 2.5 and 3. So less than or equal to x, less than or equal to 3. I'm going to write it just this way because that's how it's written on the quiz. Oh, excuse me. I sneezed there, but I muted it. All right, anyway, I'm not going to write it in interval notation just because it wasn't written in interval notation on the quiz. All right, so now range is focused on y values. Range is focused on how far up and down it goes. So now we're focused on its y level, right? So we're going to start with wherever the lowest is, right? So we're going to remember lowest and highest, low, high here. Remember domain was left to right. Range is going to be low, high. So the lowest point is here. Now, you don't really care that it's all the way over at 3. What we care about now is the y values, right? We care about this point is down here at this level. So if we trace it out, it's halfway between negative 8 and negative 12. So we can confidently say that this is about negative 10 is its lowest. And then we'll think about where its highest is. Well, its highest kind of is in 2 areas, but it's all the same thing, right? Its highest is here and here, which at that altitude is at 16. So its highest is 16. Now, there's no open circle right at the top there. There's definitely going to be some kind of point there, whether it's emphasized or not. So it does equal up to 16. It also has a closed circle down here, so it definitely equals up to negative 10. So negative 10 less than or equal to y, less than or equal to 16. This is saying that the y values range between negative 10 and 16. Now, don't get confused by these inequality signs that you see in the middle here. All this is essentially saying it's always going to be pointing this way as well that you see in the picture or in the way that I've written it. And the reason is because essentially we're saying negative 2 point, like for example, let's start with the range, right? Negative 10 is the smallest, y is bigger than negative 10, and 16 is the biggest, y is smaller than 16 because 16 is the biggest. So y is essentially in between negative 10 and 16. Smaller number on the left and then the bigger number on the right. It's kind of indicating a smallest to biggest range there. All right, now I'll focus on increasing. Now increasing, here's how I like to do it. I like to take my pencil and trace the function from the left to the right and then determine whether I'm going up or down. So if I trace it from the left to the right, the first thing I'd notice is here I'm going up. I'm going up until I get to that point, and at that point I make a turn and I go down, and I go down until here. And then I notice when if I continue drawing my pencil, right, I'm going to go up again at this part, and then finally make another turn and go down again here. So my green is my intervals of increasing, my red is intervals of decreasing. And this is very similar to domain. You want to think about this, I like to draw these lines on my graph to sort of help me see my intervals. Some of these intervals are really small. Some of them are a little bigger. Imagine those were straight, by the way. That would be helpful. It's increasing. Let me see if I can do this a little bit better. Okay, not a whole lot. It's increasing in this very, very small window right here, which is, if you're relating it, remember, all we're focused really on is our x-axis. This is from negative 2.5 to negative 2 is that interval of where it's increasing. So from negative 2.5 to 2. We're just going to say regular to 2. There we go. Oh, negative 2, sorry. From negative 2.5 to negative 2. But that's not the only place it's increasing. It's also increasing, as we mentioned, in this interval here, which is, remember, relation to our x-axis from 0 to 2. So from 0 to 2, it's increasing as well, 0 to 2. So decreasing, same idea, but in the other places. So it's decreasing in this interval, which is from negative 2 to 0. Negative 2 to 0 is where it's decreasing there. So negative 2 to 0. And then it's also decreasing on this last interval, which ends, by the way, at 3. Because remember, domain stops at 3. Its last interval here, from 2 to 3, it's also decreasing. So from 2 to 3. All right. So I've made my picture pretty messy. Hopefully that's not too bad. But now we're going to focus on max and min real quick. So we have a few points of interest. So maximum values, was that first? Maximum values, we definitely have two relative maxes. We have a point here, it's a relative max. That's at negative 216. And we have another one here, which is at positive 216. So two relative maxes at negative 216 and positive 216. You can also consider our minimums. So we have relative minimum here, here, and here. So those 3 points, if you look at them, it's negative 2.5 and 12 is one of them. Negative 2.5, 12. You also have one at 0, 0, 0, 0. And we have one here at 3, negative 10. 3, negative 10. Those are your relative minimums. Okay. So that answers all of that question. Let's try to do the same thing with this question. So our domain. Now notice the arrows on this one, right? Remember, domain is thinking about left and right. So we don't really care whether, we understand that arrow is going up, but we can't think of it like that for domain. What we're thinking about is how far left this graph is going to end up going and how far right this graph is going to end up going. Obviously, they go up and down, but this side here, as it goes up, notice it's going to go further and further left. As it extends past this range, right, it's going to continue to move further and further left. Assume that that was a good line, right? Again, I keep messing up. It doesn't really matter. It's always going to move left. It's moving past negative 2. It's going to move past negative 3. It's going to move past negative 4. It's going to continue going left and left and left. And because it's an arrow indicating it's going on forever, it goes left forever. And same thing on this side. This side, yes, it's going down, but you'll notice as it goes down, it moves to the right as well. It's moving rightwards. So it's going to go past 2.5 here in the graph. It's going to go past 3. It's going to go past 4. It's going to go to the right continuously. It's never going to go straight down. It's never going to turn back because the arrow is indicating that it's just going to continue going down and right. So what we're saying is that this indicates it's going left forever, and this indicates it's going right forever. Meaning that the domain will go all the way to negative infinity to positive infinity. All right, make the infinity signs look a little bit better. There you go. Okay. Now, range. Remember, range is focusing on, what did I say? Low, high, bottom, top, whatever it is. Lowest, highest. Now, this one's a little easier to see it because the arrows indicate more up and down than they do left and right. But this arrow is definitely going up, and it's going to be going up forever. This arrow is going down. It's going to go down forever. So pretty self-explanatory. This one, it's going to go up and down forever, meaning it's going to go from all the way down to negative infinity and then all the way up to positive infinity. What I mean by this infinity, by the way, if you think of our x and y axis, right? Yeah, we only see this axis basically going like to 3 and like to 8 and stuff, right? But essentially, all the way at the very top would be infinity, negative infinity, infinity, and negative infinity, right? This is obviously way beyond like a billion or trillion or whatever, right? It's not just going past 3. This is like going on forever, this would be towards positive infinity on the right and on the top, and then negative infinity if you went down or left. So infinity is kind of the indication of just going forever in that direction, right? To the end in that direction. All right, so increasing and decreasing. So remember, start from the left side of your graph, right? Trace the function and tell me when you're going up and when you're going down. So at first, from left to right, we're going down till about there. And then we make a shift and we start going up. We start going up until there. From that point, we go down again, right? We're going down again. So there's your increasing and decreasing interval. So the red's decreasing, the green is increasing. So the increasing interval occurs between -1 and +1 in this region here. So it's increasing from -1 to +1. Now it's decreasing everywhere else. It's decreasing in this interval here, which remember goes all the way from negative infinity up to -1. And it's decreasing in this interval, which goes from 1 on forever towards positive infinity. So all the way from negative infinity all the way up to this line, it's decreasing. So that's saying from negative infinity to -1. Oh, hold on. Keep forgetting my signs. Right? And then the other one is saying from +1 on forever, right, to positive infinity, it will always be decreasing. So from 1, and then everywhere past 1, it's decreasing. So from 1 to positive infinity. All right? And then we'll look at our max and mins. So we have a relative minimum here and a relative maximum here. And that's it. That's all we can see. So our relative maximum is at 1, 2, based on that order pair. So 1, 2. And then our relative minimum would be at this point, which is about -1, -2. -1, -2. That's everything for this review. Please rewatch it again if you feel like there's any parts of it that still kind of confuse you. Maybe watching it and seeing it explained over again will help. So I hope this helps a little bit, and good luck on your quiz. See you guys next time.